Hello, everybody, and welcome to today's episode of Sadlier School Live. My name is Camberly Woods, and I'm happy to be bringing back Matthew Beyranevand for part 2 of adding parents into the equation in your child's mathematical learning and development. So thank you, Matthew, for being back with us today.
Hi, Cam. How are you doing?
I'm great, and I just want to quickly remind anyone watching, whether you're watching live with us now or you're catching the replay, drop a comment and tell us hi. We would love to connect with any of you. And any of the resources mentioned today, we will be sure to link to in the chat. So take it away, Dr.
I have to tell you, I am very excited about today. In fact, I wanted this 3 o'clock time Eastern to come so fast because I really wanted to finish the work that we started yesterday based on the ideas from the book that Hillary Kreisberg and I wrote called Adding Parents to the Equation. If you want to read it, great, but instead I am sharing all of the key facts and ideas from that book with you yesterday and today. And so I want to pick up where we left off in regards to that. And it's really trying to help you as parents understand why and how we do the mathematics the way we do it today and what your role should be. And the number one takeaway of what I shared from yesterday is that I believe that as a parent, your role should really be as a coach. We don't need or want you to be the teacher of the students at home with homework or during this virtual learning time. We want you to help coach the kids by asking them questions and supporting them and offering them a growth mindset, which we'll talk a little bit more about today. So we shift now from the ideas of what we used to do to what we ask of you. And there's a great example here. When I went to school, they would be asking very specific, direct questions, such as, what's the area of a rectangle with a width of 8 inches and a length of 12 inches? And so you do the calculations like a robot, you figure it out. Those aren't the types of questions that we see either because of the state standards or most curriculum today. Instead, it's higher order thinking that encourage you multiple ways to solve a problem and then be able to understand and explain your answer. So instead of just finding the area, it could be, what could be the dimensions of a rectangle that has a perimeter of 36 inches? And then what dimensions give the greatest area? So now you have to think, 36 by 1, 18 by 2, 9 by 4. Those all have areas of 36. Oh, wait, no. That's not area. That's not perimeter, that's area. Okay, let me rethink of things. So it's layers of thinking. And so it's applying it here. Okay, perimeter, now I understand. 36, 4 sides, it's a rectangle. What does that mean? So what we're trying to do here is not so much try to understand this is the one answer and that's the end of the story, but the thinking and the process that goes along from understanding the problem and applying it. So this is the same type of problem, but this is the more modern version. And as we talked about yesterday with the business leaders and what people are expecting of us, those are the types of skills that we really want to see students having. And another shift is a shift in what we used to call as problem solving. When we look back at it, we now talk about it as people being problem performers. And this has a lot to do with just regurgitating and solving steps, but without requiring any sort of thinking. So what we used to do is we would do it just like the teacher did. The teacher shows a problem, I copy it down on my notebook, and then I do 20 or 30 of the exact same type. But instead, what we're trying to do now is encourage that creativity. And that's one of the things that we talked about yesterday about the importance of creativity as being a skill that workers are looking for. So what used to be a problem performer was we just take those numbers and we plug it in to the legs of a hypotenuse to try to determine the hypotenuse. Well, that's not just what we want now. We need to think about what we're doing and why we're doing it and identify, I want to use the Pythagorean theorem to be able to solve that. Before, it's work independently and speed is important. Now it's about collaboration and being able to support your answer. And finally, we used to be very concerned about answer focused. Do you have the right answer? Yes or no? If you do, you get a thumbs up. If you don't, it's no. And I'm going to move on to the wrong person. To the next person here. Now it's about communicating your process. Even if you have the incorrect answer, and if you look at one of my master classes, we do this amazing activity called My Favorite No. It's okay if you have the wrong answer. It's about communicating and justifying, and that term we used in yesterday's mathematical discourse. Those are the things that are so important to mathematics today, especially at the elementary level. And that is what we are trying to push forward. And it's very important that parents understand these differences so that they can better support their students. And something that if you've listened to me talk at all, you will always hear me share, and that is to have the growth mindset and not to be able to say, I can't do math, I don't want to do math, I could never do it myself. Because if your child hears you say that, then you are the role model and they are going to believe the same thing. Just like we would be embarrassed to say, I don't know how to read. We should have those same feelings about math. If you don't feel comfortable with math, that's okay. We can work on that, but let's not share those thoughts and feelings with our own children, because then they might start to feel the same way about it. And what I think is a great thing to be able to see, and I want to share with you, is different ideas in mathematics as how it can be transferred from the lower elementary level up to middle and high school. And one of the things I always hear parents say is that, why do I have to use the area model? Why do I have to be able to do arrays? I could just do the quick methodology. And I have a few examples here that shows you why and how we do this. So arrays are different ways to arrange objects so you can see basically the beginning of multiplication. And then we have this idea of an area model. So if we say, okay, something is 3 by 4, then the area inside is 12 inches squared in this particular example. This idea of area model is the same way in which we teach multiplication. So we break down values. Instead of doing 73 times 27 with the standard algorithm, we want them to understand it. So we go back to that area model and break down 73 to be 70 plus 3 and 27 to be 20 plus 7, so that they are bringing back their prior knowledge and being able to apply it now with the multiplication of two-digit numbers. And when we get into higher level mathematics, such as middle school, high school, and we start doing that dreaded algebra, we have the exact same ideas. Instead of 20 and 5, it can be 2x and 5. Instead of 30 and 2, it's 3x plus 2. And then you're doing the exact same thing. You're finding the areas of the smaller rectangles, you're combining like terms, and you're coming up with an answer. So the idea of what we do with area models beginning in 3rd grade is the way we teach going up through at least Algebra 1 into Algebra 2. So if you think you're doing your child a service by saying, no, forget that area model or using arrays, let me teach you that standard algorithm so that they don't need to learn that. Well, I believe we're doing them a disservice, because then when we teach them using the area model for pre-algebra and algebra, they are at a significant disadvantage. And one final thing I want to end with. If you say to yourself, parents, what is it I should be doing to be able to support my children as they learn math? Here are a few of the things. The first thing is that we want to just trust the process. The teachers, the educators, the leaders, we are trying to do the best we can by your child. And if you feel like we are confusing, talk to us. We will assist and help you with it. But we really believe that what we are doing is in the best interest of your children. Second is, if there's terms that you're not aware of and your child may not know because you asked them first, just take a few minutes and Google it and look it up, as opposed to just giving up on it and saying, nope, we're not going to do it that way. Try to learn yourself or contact your teacher. And third, have that positive mindset. Have a growth mindset. It's okay if that's not how you learned it. Encourage your child for them to teach you how they are learning it so you can understand. Please don't, quote, poo-poo the methodology that your children are learning. And finally, your teachers are there for help. Now, when we have this virtual learning that goes on today, they are even more willing and able to help you, as for many cases, you are their primary, not teacher, but you're the primary educator at home organizing. Keep that communication going with them. We all want children to enjoy math, understand math, and love mathematics. And if you can follow some of these ideas that I have shared, it's going to not only better your relationship with your child related to mathematics, but it's going to help them be a lifelong critical thinker, problem solver, creative mathematician that we want them to be, and also that business leaders want them to become. So that was a lot in a short amount of time. What do you think? What do you think about that, Cam?
So a couple things came to mind, and one of it was that in yesterday's video, we talked about how our role as parents right now isn't to be the math teacher, but more of a math coach or a math cheerleader who's cheering those children on. And so I think like that last slide where you're talking about what we can do as parents and relying on the teacher for support, like, again, we are not the teacher. So rely on those teachers for support if you need it, number one. And number two, I love the example you gave of if your child is doing a math problem a certain way that you didn't learn growing up, instead of teaching them your way, why don't you ask them, well, you show me how, like, I want to understand your way. And then that's going to deepen their understanding further. When
right, a total win-win. It deepens their understanding and helps the parents say, oh, that's why you're doing it this particular way.
Yeah, and I actually had this happen a couple months ago with my daughter who's only in second grade, and she was doing addition with triple digit numbers or 3-digit numbers. And the way she was breaking things down into different arrays and stuff, I was like, this is totally different from how I was brought up and what we did in school. And instead of telling her like, no, let's carry the one and do it my old traditional way, I did what you said. And I said, well, show me how you're learning it. And then she was able to deepen that understanding. I was able to learn a totally different way into calculating into that addition. So it's a win-win.
Well, good for you for looking at it with an open mind and being willing to, you yourself feel a little bit vulnerable that you're helping your child and you might not immediately understand it. And that is a tough thing for a parent, but it's something that we have to just be willing to accept and say, yep, I'm not familiar with that. How about you help me and show me how to do it?
Yeah.
Boom. Easy as that. And you will get some great results.
And I just didn't realize this was going to be happening so quickly in just second grade, where I would already be up front facing this type of issue, but it's definitely happening.
Yeah. And that's really what that shift is that's been happening over the last few years, is that we really want them to understand the mathematics, solving it multiple ways, understanding it multiple ways. They are not computers. We don't want them to be computers. They're smart kids, and we want to be able to get the most out of them and be able to enjoy the mathematics.
I love it. Now, I want to remind all of you that in the comments on today's live, I've linked to a couple of things. The first one is the part 1 training that we did yesterday. So if you have not had a chance to watch that, you want to take advantage of it, that is in the comments. And the second thing is I linked to our past masterclasses and webinars that have been done by Dr. Matthew Beyranevand. And one of the classes on there is the one he did on growth mindset, which I know he mentioned on today's training. So you can also access that training at the link in the comments.
Well, I'm so excited. I hope people will check those out. And I look forward to next week being on with you Tuesday and Thursday to kind of continue these conversations about how parents can better support their kids with mathematics. And the feedback that I have been hearing is that people really enjoy it. And I'm really thrilled to be working with you, Cam, doing this.
Thanks. I have been enjoying it just as much. So thank you for being here. And as Dr. Matthew mentioned, we will be back tomorrow at 3:00 p.m. Eastern, 12:00 Pacific. So we hope to see you there and have a wonderful day.
All right. Thank you. Bye-bye.
Bye, Matthew.